In last section, I have discussed about shallow foundation or different types of shallow foundation and how to design the dimension of the shallow foundation based on the settlement and the bearing capacity calculation. Now, in this section, I will discuss about the deep foundation. Now, as I have discussed, the shallow foundation means the depth of the foundation is very shallow. Now, in the deep foundation, if the load is amount of load which is coming on the foundation is very high and the soil is not capable to take that load if I provide or if we provide a shallow foundation, then you have to go for the deep foundation, where the load carrying capacity of the foundation that will increase if we use the deep foundation, and definitely the depth of the foundation is much high as compared to the width of the foundation. So, in the shallow foundation, we assume that if the depth and width of the foundation are more or less equal, then or within, if the depth of the foundation is less than the width of the foundation, then we talk about the shallow, that is a shallow foundation. But if it is more than its deep foundation, in its that is a guideline. So, that is why in the deep foundation the depth of the foundation is very high. So, basically first I will discuss about the pile foundation. Then in the next module, I will discuss about the well foundation or the so these are the different types of deep foundation. Now, this introductory class of the deep foundation, I will discuss about the different types of deep foundation, basically in the pile foundation in this section. And then what are the construction methods, then how to calculate the load carrying capacity, and what are the different types of foundation, pile foundation based on the loading patterns. So, first I will go for the pile foundation. So, that is our first So, this deep foundation, first we explain this pile foundation. Now, this pile foundation, so that is we can draw, if this is the a typical pile, and we can write this, say this is the ground surface, or here we can provide the pile cap, and then this is the width of the, or the if it is a circular pile, this is the diameter of the pile, and this is the length of the pile. So, here we can see that the length of the pile is very high as compared to the depth of the, or this width of the pile or diameter of the pile. So, here the load carrying capacity, I will explain for different types of loading and the how to calculate the load carrying capacity of the pile, and here also there are two types of criteria, one is load carrying capacity and another is in settlement criteria. So, we will consider all this aspect when design this pile foundation. So, what are the load? First we will talk about the load. So, there first is we can say this is the vertical load. Then one type of load is horizontal load. Horizontal load. And the third one is the combination of vertical and horizontal. So, these are the different types of load that is acting on a pile foundation. So, now this vertical load and that can be upward or downward directions. Now, if this pile, so different types of piles based on their performance, we can write one, first one is end bearing pile. So, this is basically for the, suppose here when we suppose this is the vertical load we are applying here. So, that the resistance this pile is getting from the soil is, one is the bearing that is the resistance at the bottom of the pile tip, and another resistance from the friction between the pile surface and the soil. So, the load carrying capacity, this P, if this is P, this is acting here. So, this is due to the friction and this is end bearing. So, if I write the contribution from the friction is Q F and contribution from the bearing is Q B. So, we can write the total load that is taking by from the contribution of bearing plus contribution of the friction. So, we can say that end bearing piles, now if the contribution of the bearing part Q B is very high as compared to the Q F, then this type of pile is called the end bearing piles. So, that means the contribution is Q B is more. So, that means the contribution Q B is more, which is generally can observe that sandy soil and next one is the friction pile. So, sandy soil or the poor soil. So, that type of contribution is more the bearing. In the friction pile, if the contribution of Q F is more. So, this is the soft soil or soft clay will get this type of pile. So, now if the contribution from the bearing is more, that is the end bearing pile, that most of the loading is taken by this point resistance or the bearing, that is end bearing piles, and if the most of the loads is taken by this friction resistance, that is for the friction pile. Now, depending upon the different type of loading, as I was discussing about the vertical loading, horizontal loading and combination of vertical and horizontal loadings, we can write pile in different types. One is generally pile is used to resist the compression load. So, now this type of pile, one is your compression pile. So, vertical load, that can be two types. One is compression, another is tension or uplift. Now, this compression type of soil, which is very common for any structure, generally these piles are used to against the compression load, but in the tension load, that means the vertical load, it can be compression means the downward direction and tension means in the upward direction loaded direction, but both are vertical loads. Now, this tension load or the uplift load, that is basically suppose is applied for a tall building or any, suppose this is the, we can write the different combination of the pile. Suppose this is our one pile or one building pattern. So, this is the, these are the different types of piles, and here this is a very tall building and we can write the, this is the plan, and suppose this is the plan of this tall building. So, now if the load lateral load or the wind pressure which is acting in lateral direction. So, in direction this total system will go in this side. So, here we can say that these piles, these will be subjected the compressive load, and these piles will be subjected by tension load, or this is the uplift load and this is under compressive load. So, these piles are called the. So, here we have to design these piles against this uplift load. This is the tension pile. This similar case can be happen for the foundation pile foundation below a tall chimney, where also we have to design these piles for both compressive load as well as for the uplift load. Now, this direction of this vertical load, this can be perfectly vertical or it can be inclined also, depending upon the type of structure or the type of loading that is acting, that can be inclined also, that inclined compressive load or inclined tension load. So, now this is the vertical load. If we are talking about the horizontal load, so that is used for the foundation for retaining wall. So, there we can. So, this is again the two types. One is your laterally loaded pile, now this laterally loaded piles, the definition we can write that if horizontal load acts perpendicular to the pile axis. So, that means suppose we can, if we draw this pile and this is the pile axis. Now, if the load is this horizontal load is perfectly perpendicular to the horizontal axis of the pile, then this is called the lateral loaded pile. Now, another one you can say that is the batter pile. So, here piles are driven at an angle. So, we can write, say, suppose this is the batter pile, where piles are driven with an angle, with this depending upon, suppose these are the called the batter piles or inclined piles, to resist the inclined load that is acting. So, here this load is inclined. So, that is not perfectly perpendicular to the axis, it is somehow inclined load. So, to resist against this inclined load, we can sometimes use this pile, which is called the batter pile or the inclined pile. The next one is the compression, or the next one is the compaction pile. So, these are the short piles used for compaction. So, sometimes for compacting the soil, basically the sandy soil, we can use the pile, short piles. These type of piles are the compaction piles. Now, the different loading condition, this uplift load that is used for the tall structure or the chimney structure, compressive load which is common for any type of structure. Now, this lateral load that is used for, suppose we provide the foundation for retaining wall, where the lateral load is coming, or for any offshore structure where the loading from the this sea water or that load is lateral type. So, there we can use the lateral load, we can load can come. So, there where we can use the lateral loaded piles or the batter piles. So, these are the different types of loading and the different types of structure. So, again we can use design for different types of piles, that is compressive, design against compressive load, design against uplift load, and design against lateral load. So, those things we will discuss in this section. So, next types of piles, or further if I classify these piles, so one is based on the material. Suppose based on the material of construction, so pile can be, one is timber pile, pile can be made of steel, concrete, and then composite type of material also. Now, the next one, the based on the cross section, this pile can be circular, that can be square, that can be I section if it is a steel pile, that can be H section, that can be hexagonal, etc. Now, based on the shape, this pile can be cylindrical, which is very common. Then it can be tapered pile. So, cylindrical means suppose this is the, so diameter, this diameter of the pile is throughout constant, and tapered it can be, suppose this is the tapered type of piles, where the diameter is not constant, or it can be either type also. Depending upon the type of soil. So, this is the tapered piles, then this is the under rim piles, under rim piles. So, here this is the tapered piles, these are cylindrical piles, and under rim piles. Suppose here some bulb is constructed, so this can be single bulbed or double bulbed. So, these are the tapered pile, where this diameter is higher compared to this diameter. So, these are the specific shape of the piles, and where the different type of soil we can use the different types of pile. This is the common in cylindrical shape, this is a tapered shape, because here if we need the more bearing tip resistance, that means in end bearing piles, here we can use this enlarged base, and this is the under rim piles, where we can get the additional bearing capacity for this under rim bulb, or we can provide this one for the resist the negative skin friction also. We will discuss these things later on, what is this negative skin friction and how we can design these under rim piles, etc. So, next one is this mode of load transfer. So, again we can say this is the end bearing pile, all friction pile, or we can say this is tension pile, that can be lateral loaded pile, or compressive pile. So, there are different types of load, these are different types of piles. The next one by this E type, that is based on the method of formation. Forming that can be precast, that means cast in situ, and pre-stress also, etc. And based on the method of installation, that can be driven or board piles, etc. So, these are the different types of piles that I have explained. Now, next one is the for the timber piles, that we are talking about these different types of piles. Suppose first when you go for the timber piles, these timber piles is generally used up to say 30-meter long, and which can carry a load from 100 to 250 kilonewton per pile. Now, steel piles, these are the small displacement piles and used to carry heavy loads and up to 40 meter of length, and it can carry 1800 around kilonewton per pile load. Under the driven precast piles, usually or driven precast concrete piles. So, this is driven precast concrete piles. So, these piles are usually in a state of compression. So, now this is or in the cast in situ concrete pile. So, these are the different types of piles are used. Now, next one I will discuss about the different type of load bearing capacity, how to calculate the load bearing capacity of the pile or different piles. Now, first we will go for the pile load carrying capacity. So, in compression, so the first will, so there are the different types of load carrying capacity. One is compression, one is tension, another is lateral load carrying capacity. So, first I will discuss about the compressive piles against the compressive load, then later on I will discuss the other cases also. So, this one first I will discuss this load carrying capacity of the pile. So, the expression that we will use, that is static pile load formulae. Next one is the pile load test. By pile load test also we can calculate the pile load carrying capacity. Third one, the pile driven or driving formulae. Next one is the correlation with penetration test data. So, these are the different methods by which or we can determine the pile load capacity in under compression. Now, first we will calculate the static load carrying capacity of the pile. So, by the static load form expressions. So, and these are we are talking about the compressive load. compression under or compressive load. Now, when we are talking about this, if this is the pile, so as I have mentioned that we will get the resistance from here, that is Q B, and this is a total load is acting, and this is the frictional resistance. This is Q F. So, the ultimate load carrying capacity of the pile Q U, that is equal to Q B plus Q F, or here we can write in place of P, this is Q U. So, ultimate load carrying capacity of the pile. So, this Q U is summation of the Q F plus Q B, one coming from the resistance from the tip, one from the friction. So, this is the ultimate load, and this contribution from the ultimate frictional resistance, and Q B is the ultimate point load. So, this is the total ultimate load is ultimate point load plus ultimate frictional resistance. So, here when we apply the load, first this frictional resistance give the support, when this, and then the load bearing capacity of the end bearing that will give. So, first friction resistance that will mobilized, and then this is mobilized, then the next one, next the end bearing capacity that will give the support. When we apply the load, then first the frictional resistance that will give the support, then the end bearing will give the support. Now, as we have mentioned that if Q U is much or Q B is much greater than Q F, that pile is called end bearing pile. And now, if Q F is much greater than Q B, then this is called the friction pile. Now, here we will calculate the pile load carrying capacity. So, first we can write that Q U or Q U B, that means the ultimate load carrying capacity of any foundation. Here we can say this is the ultimate stress of the base soil or the base of the pile, that means the bearing resistance that we are getting from this toe. That expression we can write that C N C plus sigma bar N Q plus 0.5 gamma B N gamma. So, this is common as the shallow foundation bearing capacity expression. So, that same expression you are using here to determine this bearing end bearing capacity of the pile. So, this is the only the Q B part. So, that means this is the stress carrying capacity, where B is the width or diameter of the pile, and sigma bar is effective overburden pressure at the tip of the pile. So, now we will calculate this expression. Suppose if we calculate the general expression, that here we can write that Q U B, that is equal to C N C plus sigma V is sigma bar N Q plus 0.5 gamma B N gamma, where again this C N C N Q N gamma as the bearing capacity factor and gamma is the unit weight of the soil and C is the cohesion of the soil. And now, here we can see that suppose this is the pile we are talking about and this is the total length of the pile and this is the B or D of the diameter of the pile. So, the contribution we can see that here for the contribution. So, sigma V we can write the sigma bar is gamma into L. So, this is the gamma or unit weight of the soil at this region. So, this is gamma and if I talking on the same soil. So, this is also gamma, otherwise we can consider if it is the layer soil a different layer intensity you have to consider. So, now this is our Q L and the contribution from here. So, that means, this second contribution is the contribution that is we are getting because of this overburden pressure of the soil and the third one we are getting because of this only this region. So, that this contribution is very small compared to the contribution from this overburden pressure. So, that means, the second part we can say that sigma bar N Q is much higher than the 0.5 gamma B into N gamma or the third part. So, we can write that Q U B is equal to C N C plus sigma bar N Q. So, neglecting the third part. So, now for the granular soil, we can write Q U B is equal to sigma bar N Q as for the granular soil purely sandy soil C dash equal to 0. Now, for a clay soil or clay soil, we can write that phi u is equal to 0. So, Q U B will be C N C, where C is the cohesion. So, finally, when this is the phi u value, phi u is 0. So, that Q U B is C N C. So, when we calculate this total Q B, that is equal to Q U B into A B, where A B is the cross section area of the pile base. Similarly, Q F will get that frictional resistance F s into A s, where F s equal to unit kiln friction resistance and A s equal to surface area. So, now we will calculate the other parts. So, how to calculate this skin friction area. So, now we have to calculate. So, we know how to calculate the tip bearing resistance. Now, we will go for the skin friction. So, the F s we can write this is sigma h into tan delta. Now, what is sigma h? Suppose this is the pile that we are talking about and this is the resistance, friction resistance is acting here. So, suppose this is the at the center point we are talking about sigma h, that is the distance at L by 2, and this is the total length of the pile L, and delta is the frictional angle between the soil and the pile. So, that means the friction resistance that will be sigma h, lateral force acting in this direction, and the tan delta. So, here delta is the angle of friction between the pile and soil, and sigma h we can calculate, that is k into sigma v. So, sigma v is the vertical load acting, k is the coefficient of lateral earth pressure. So, the q f we can write, that is sigma a is average into s, and sigma a is average, that is bar, we can write, that is k into sigma v bar into tan delta into s. So, here sigma v bar is the average effective overburden pressure over the embedded length of the pile. So, here this sigma average is calculated at the center or the middle of the pile length. So, that means, if the length is L, we will calculate sigma h at the center. So, that is the average sigma v we will calculate, and based on we will multiply this by k, we will get the sigma h, and then we multiply the tan delta, we will get the average friction resistance, and then we will to multiply the total thing as the area of the surface area. So, then we will get the this friction resistance of the soil. Now, the next one, that how to get this k value for the different pile material. Suppose that the pile material, if we consider the steel, then the delta value, this is suppose the material, and this is the delta value that we are getting. Suppose this is 20 degree, and the k value that we are getting, that for the loose sand, and this is for the dense sand. This is 0.5 and this is 1. For the concrete, this is 0.755, this is 1, this is 2. For timber, that is 0.675, this is 1.5, this is 4. So, these values we are taking from this Ranjan and Rao book. This is 2003, this reference. Now, one thing that we are talking about this pile in cohesionless soil or the granular soil. So, this frictional resistance we are calculating. So, this frictional resistance that we are calculating, this is for the granular soil, that means sand or gravel. So, this friction that we are calculating, this friction we are getting, that is basically for the sandy soil or granular soil. So, here we will calculate this total sigma v into tan delta, and then multiply this friction resistance, we will get this value, and this is the k value we will getting. So, here is we are talking about the granular soil sand, that is why we are talking about the loose sand and the dense sand. and different materials, steel, concrete, timber, delta will consider 20, if it is concrete will consider 0.755, and for the timber you consider 0.675. Now, the thing that when we are driving a pile into the soil, and then you have to calculate this effective overburden pressure, because here for the granular soil we will use this calculation NQ and sigma bar or sigma bar, that is the effective overburden pressure. So, NQ will calculate from the table, and this NQ bar, this NQ will calculate from the table. There is few tables are available. So, that chart, from this chart we will calculate the NQ, and sigma bar we calculate by the calculation. So, when you calculate the sigma bar for the Q U B, so that is sigma V NQ, and then we will calculate this phi C is phi plus 40 degree plus 2. So, this is for the driven pile. So, if the granular soil, if the soil is phi less than 40 degree. So, because of this driving of the pile, the soil will get compacted. So, that the phi value of the soil that will increase because of this driving of the pile in a loose type of soil. So, that means the average value or the phi value that will increase. So, that is why we are taking this expression, if this phi plus 40 degree plus 2. Now, if this phi is greater than 40 degree, then the pile driving shall have the effect of reducing the angle. Now, if the phi value is 40 degree, greater than 40 degree, then due to driving of a pile, phi value will reduce because of the dilatancy effect, because if the phi is 40 degree, then it has become a very dense type of soil. Now, if there will apply the driving pile, then the phi value reduce due to the dilatancy effect. So, that is why you have phi will calculate phi plus phi 0 plus 2. When you calculate this NQ, this NQ there will use this, suppose if it is less than 40 degree phi value, then instead of using that phi, we will multiply, we will add this phi with 40 degree, and then we take the average, because here the actual phi will increase because of this driving of the pile in the loose soil, and then based on that phi C will calculate the NQ. But if the phi is greater than 40 degree, then because of this dilatancy effect, the this phi value will reduce. But another thing, here we are considering that Q B is equal to sigma V into N chi, but IS code recommends that considers the 0.5 gamma B and N gamma in addition to sigma V N Q. So, that means, here in IS code recommend that you have to consider this third part that you have neglected in this expression in addition to this one. So, they will get the contribution from this one also. So, but actually this contribution, if this is very less compared to this one, we can neglect this one, but actually according to the IS code you have to consider this part also when you calculate this QUB. So, now this is the pile for the friction granular type of soil. Now, the next one will get the piles in clay. So, pile in clay will take this Q, total Q ultimate load is again QUB into AB plus Fs into S, same as. So, here in clay QUB, that is C N C we are considering, and Fs that we are taking, that alpha into Cu, that is Cu B, and this is alpha into Cu, or we can write this is Cu B into N C, and this is alpha into Cu, where Cu B is the undrained cohesion at the base of the pile, and N C is the bearing capacity factor, now for circular and square, this N C is equal to 9 as proposed by the Skempton. The here condition is that the pile must go at least 5D inside the bearing strata. So, suppose if this is any bearing strata and this is the pile. So, this is the bearing strata here, this distance that should be greater than 5D. So, this is the soft strata and this is the bearing strata, and this one is the bearing stratum. So, here we calculate this N C and we will get the Q B, and for the other part we calculate that alpha is equal to adhesion factor and Cu is the average cohesion in the embedded length of the pile. This is the undrained cohesion into the or through the length of the pile. So, this is the undrained cohesion into the embedded length of the pile. So, in this way we can calculate the phi value now. So, now in the pile in the clay soil, that we will get this expression. Now, here this is total, this C U B into N C plus F S into A S, this is into A B. So, the expression is C U B into N C into A B plus F S is alpha into C U into A S. So, C U is the undrained cohesion throughout the length of the embedded pile, C U B the cohesion at the base of the pile, N C if it is circular and square we will get the 9, A B is the base area, A S is the surface area. So, you all know these things. So, this alpha value we have to calculate, this adhesion value we have to calculate. Now, for different types of soil, so suppose based on the consistency, so and we will get the alpha value. This is for the boat pile, and driven pile. So, here as I have mentioned that the two types of piles, one is boat piles and another is driven piles. So, these driven piles is cast in situ driven piles, or this can be precast driven piles also, and this is another one is the boat piles. And now, here different types of piles, this is if it is soft soil, soft to very soft. For the boat piles, this alpha value is 0.7 you can take, and for the driven cast in situ piles it is 1. For medium stiff, this value boat pile value we can take 0.5 and this is 0.7. For very steep soil, we consider this is 0.4 and this is also 0.4. For steep to hard, so consider this is 3.3, this is also 0.3. So, these values also it is taken. So, these are the value alpha value or the adhesion factor value we will get for different types of piles from this table. Now, in this section I have discussed about the different types of the piles that we are getting for and how to calculate the bearing capacity of the pile. So, we are talking about the single piles. Now, actually in the field the piles are used as a group. So, now we have to calculate the group efficiency or group calculation of the piles, because these the piles I have discussed, this is the load carrying capacity of the single pile, it is not a group pile. So, load carrying capacity of the single piles in cohesive soil or cohesionless soil. So, then the resistance that we are getting, that is from the base and on the friction. Then how to calculate the friction resistance for the cohesive soil and the granular soil, then how to calculate the end bearing capacity for the cohesive soil and the granular soil. Those things I have discussed, but this all things are in for the single piles. But actually when you use these piles in a group, so then you have to calculate the group load carrying capacity of the piles. Now, the condition is these piles, depending upon the spacing in the groups, these piles can be either fail individually if spacing is very high, if the spacing is more, or it will fail like a block as a group if the spacing is very small. And then, so that means you have to check whether these things will fail as a block, as a group, or as an individual. So, both things you have to check, and then the minimum one to provide as the group carrying capacity of the pile. And the depending upon the spacing, the efficiency of the pile, that we can calculate the efficiency of the piles. So, whether how much efficiency we will get if we use a single pile in a group, how much efficiency it will increase the efficiency of the piles or it will decrease, that thing we can also calculate. So, those things we will discuss in the next class, how to calculate the load bearing capacity of the pile in a group, and then I will discuss about the pile load test, because here the static expressions that we are using to calculate the load bearing capacity of the this time will single pile. Next class we will discuss about the group piles. Then we will discuss about the next method, then by the pile load test how we will calculate the ultimate load carrying capacity of the piles, and then we will discuss the other methods also. So, thank you.